try this one. Let's say we had x to the 4th power minus 7x squared plus 12. Is it in descending order? GCF. Everybody's got an X? No, 12 doesn't. So can't do that. All right, so if there's no GCF, we go to counting terms. How many terms? 3. What do we do if there are 3 terms? X method. But this is not quadratic. But it's got 3 terms. So we can treat it like it is. Okay, so we're going to do the X method for this one. What goes on the top of that X? 12. 1 times 12 is 12. What goes on the bottom? -7. Okay. So what multiplies to be positive 12 and adds to be -7? -4, -3. Good. All right. Now, sorry, Coach Austin is making fun of me out there in the outdoors. Y'all check on him. He's old, and I'm putting this on video for a reason. He's old, and at his age, he can't handle his heat, so be careful. Check on Coach Austin. So, now, the difference here is that we have x to the 4th and x squared. So when we factor it, it's not going to have plain x's on it. Okay, it's going to have x squareds at least. Okay, so one thing that you could do would be take x to the 4th minus 4x squared minus 3x squared plus 12. And I want to show it this way. There is the shortcut that you can do with this one because there's nothing in front of x to the 4th. But I think you can kind of see what's happening here a little better if we don't take that shortcut. Okay, so all I'm doing is replacing that middle term like we did with the x method if it was quadratic back in chapter, well, we didn't do chapters, back when we were doing quadratics. Okay, so I'm -4x squared and -3x squared is replacing the -7x squared. And then we're going to do what? 1, 2, 3, 4 terms. Group it. What's the GCF of this first group? X squared. Leaving x squared minus 4 in parentheses. What's the GCF of that second pair? -3 leaves x squared minus 4. Notice those parentheses matched. Means I did something right. So I've got x squared minus 3 and x squared minus 4. Kind of like example I, we got to look at those and see if either of those will factor further. It's possible that both of them do. Does this one factor further? X squared minus 3. Why not? Yeah, 3 is not a square number. So that's not a difference of squares. It's a difference, but it's not a difference of squares. This is a difference of squares because 4 is what kind of number? It's a square number. It's 2 squared. Okay, so this one will factor further, so we're going to break it apart further. Okay, how does that one factor? Yeah, x minus 2, x plus 2, whichever order you put that in, doesn't matter. That's the completely factored form. So there we get some practice with the grouping and then factoring a little further after we've already done one method of factoring. There still could be more to do because we're dealing with bigger polynomials here. When there were quadratics, there was just one thing to do, but with bigger ones, you can do more.
Wait a second, how did you get the x minus 2 x plus 2?
From this x squared minus 4, it's a difference of squares. 2 squared is where the 4 comes from, so that's where we're just factoring that piece further.
Yeah, and the 3 does not have a square root, so.
That's exactly right. That's exactly right.
So
Good.
if both of them had square roots, it'd be 4.
Yeah, you could have 4 sets of yeah. Yeah. You're always going to look at your things at the end and say, can I go further with that? If we're dealing with higher degree polynomials, which is what we're trying to do right now. Let's what letter are we on? K. Let's say we had 6x to the 6th. Let's do plus plus 6. It's an x cubed there in the middle. Six x to the 6th plus 16x cubed plus 8. What are we doing here? What is the GCF? 2 goes into everybody. So we're going to divide it, pull a 2 out. So we're dividing everybody by 2. So that's 3x to the 6th, 8x cubed plus 4. Well, that's nice. Is that all we can do with this one? No. What else can we do? X method, because it has how many terms? 3. Okay, so if we're doing the X method, what goes up top for this one? 12 in the bottom, 8. Multiplying to be 12, adding to be 8. 6 and 2. You guys are better at that than you were when we were doing quadratics. Believe it or not. You might not think you are, but you are. Can I take the shortcut on this one? No, I got something in front of the x to the 6th in this case, so I've got to go the long route anyway. 6x cubed, 2x cubed, plus 4. The thing that's going to catch you on these is not the x method. You guys know how to do that. It's right here when you don't put x cubed there and you just put plain x's. That's the common mistake with this. So make sure whatever that middle term has, your pieces you replace with have the same letter and the exponent on them. Okay. I know this 2 is still hanging out here. Technically, it's still there. We're not doing anything with it at the moment. Okay, so we're going to group first 2 here. What's the GCF of those 2? 3x cubed. And that would leave what in parentheses? X cubed plus 2. Good. GCF of those 2. Plus 2. So that'd be x cubed plus 2 in parentheses. They match. Means I did something right. Parentheses matching there. So my factored form here, you got the 2 that we pulled at the beginning. What are my next 2 factors? Plus 2. And the last one. All right. Now I've got to check those to see if I can do anything else. Okay. So since I've got x cubes in there and only 2 terms, what's the only possibility? Sum or difference of cubes. They both got plus signs, so I'm thinking sums of cubes. So to be a sum of cubes, you got to be a cubic number. Is that a cubic number? Is that a cubic number? That means we're done. That's what you've got to do with these. Once you get to what you think's the factored form, check one more time to make sure those factors won't go any further. Okay? And that's our factored form. Let's solve some polynomials. Do a few of those real quick, and then I'll let you do some practice. Four x to the 5th minus 20x cubed plus 36x equals 20x cubed. Yeah, that's what I want. All right, so here we're solving, okay? So if we're solving, what does it got to be equal to?
0.
0. And then it's got to be in what order? Descending order. So when you're getting it equal to 0, make sure you're putting it in descending order at the same time. So what do I need to do to get this equal to 0? Yeah, minus 20x cubed. And I'm putting it underneath this other minus 20x cubed because they're what? Like terms. So you're putting the like terms together. So there's our 0 that we need. 4x to the 5th. That's not 20 anymore. It's 40 now. Okay. Once you get it equal to 0, it becomes a factoring problem. And since it's a factoring problem, what do we do? Greatest common factor is what we should look for first. This one happens to have 1, which is what? 4x. What's that leave in those parentheses? X to the 4th. Okay. Now, can this part in parentheses factor? It's got 3 terms. I'm going to try X method on it and see if it will. There's no guarantee that it does, but because that's what we're doing, it probably is going to. 9 on top, negative 10 on the bottom. Yeah, negative 1, negative 9. Yeah, both of them need to be negative so that it multiplies to be positive and adds to be negative. Can we take a shortcut on this one? What would the front part of these parentheses be? X squared. So we got x squared minus 1, x squared minus 9. What about that 4x that we pulled at the beginning? Bring it on down there. Now, since we're doing factoring, will either of those parentheses factor further? X squared minus 9 will. It factors as x minus 3, x plus 3. What about x squared minus 1? I wrote some up there, so I hope it does. Why does it factor? Because 1 is it's got a square of 1, right? It's got a nice square root. That's the way Ted said it earlier, and that's a good way to think about it. Now, will any of the other what we've got now factor? No. All right. Now, here's what we got to remember. Once we get to this step, we've got it completely factored. What do we do with each factor? Set it equal to 0 and solve it. How many answers am I going to get from this one? How many factors do I have? I've got 5, don't I? 1, 2, 3, 4, 5. So I'm going to have 5 answers out of that. Okay? So I'm setting 4x equal to 0. X plus 1 equals 0. X minus 1 equals 0. X minus 3 equals 0. X plus 3 equals 0. And solve each one of those. The solving part's the easy part. If you can get the factoring done completely, the solving should be the most rewarding part because it's easy. What times 4 gives me 0? 0, right? There's one answer. Subtract 1. It's negative 1. There's 2 answers. There's the 3rd answer. 4th answer. 5th answer. Is this short? No. It's long. It's big polynomials. It takes a little bit. Okay. It's not. I'm not telling you. I'm not trying to paint the picture that it doesn't. Okay. Let's do another one. Are we on M? Is that the right letter? Yes. Fun one. Let's. What do we do first? Add 6x to the fourth. Why are we doing that? Get equal to 0. And then I'm putting it in descending order after that. Now
High school hallways, we cannot run the AC. No air conditioner in the high school hallways today. Thank you.
I don't say I have my fingers crossed in my pocket, but she's going to come. Teacher, she went down. That's what I was hoping she was.
Well, that's fantastic.
My thoughts exactly. That's fantastic. All right. What do we do next? GCF. We're always going to look for that first. These examples have one because not everyone does, but they have one because it makes us do a little bit more and get that practice. So what's the GCF of 6, 27, and 15? 3, and then an x squared is how many x's they have in common. What's that leave in those parentheses? Plus 5. Okay. Now, we're factoring here, so I'm going to use factoring to solve this. But since I'm solving, what other option do I have to solve the parentheses part? I could use quadratic formula to solve this. I'll do it both ways with you guys today. It doesn't matter. Why can I use quadratic on this? Because it's a quadratic equation. You know, it's x squared, plain x, and it's a, b, and c, right? That makes that legal to use, okay? Since you're solving, you can do that. If you're factoring, you've got to factor it, okay? So if it's got the equals, then you're solving, and so that opens up quadratic formula. If I wanted to factor that, I'd do the x method, 10 and negative 9. Multiply to be positive 10, add to be negative 9. Is there anything that does that? Negative. Well, it'll have to be negative 10 and negative 1 to multiply to be positive.
Oh, yeah.
And that doesn't work, so it's not those. What about negative 5 and negative 2? That's negative 7. It doesn't add to be the right thing. Is there anything else that multiplies to be 10? No. So will this even factor at all? No. That happens. Okay? So that means we have to use what? Quadratic formula. Okay? So we're going to set both factors equal to 0. We got 3x squared equals 0. And we got, I'm going to erase that because we're not using it. 2x squared minus 9x plus 5 equal to 0. So we got those two to do. This one's easy. How do we get x by itself here? Divide by 3. X squared is equal to 0. Take the square root to get rid of the squared. And what's the square root of 0? 0. That 0, we call it has a multiplicity of 2 because it came from x squared. So this 0 counts twice. Okay, so when we get done, I'll show you what I mean here. Now, we know we're going to do quadratic formula on this because we've already tried to factor it and it didn't. Okay, so equals negative b plus or minus 1. Yes, sir.
Couldn't we just take what could be 3x and what 3x equals and insert it into the equation?
No.
Okay.
because that 0 is a solution to the whole larger polynomial, and that doesn't necessarily mean it's a 0 or an answer to this part of the polynomial, the factored form. But it is an answer to the original polynomial. So that's why we can't do that. Good question. All right. So quadratic formula, just reminding you of that. Nice little thing. And plug in the stuff. 9 plus or minus 81 minus 4 times 2 times 5 over 4. What's that part under the radical or the square root called? I remember? Discriminant. And what's it tell us? How many answers and what kind we would have. Remember, if it's negative, what kind of answers are we going to have? 2 complex. If it's positive, we're going to have 2 real solutions. If it's 0, we're going to have 1 real solution. Okay, that one's obviously not 0 because 80 minus 40, 81 minus 40 there would be 41. Can we break down 41? No, 41's prime. That's my exact solutions. Oops. What's the decimal approximation for those? Nine plus the square root of 41, and then divide that answer by 4.
Okay, so with that the quadratic solution set right there.
Mm-hmm. That one that's underneath the.
So is the discriminant? Isn't it the discriminant is over 0? You have 2 solutions.
Yes, 2 real solutions. So discriminant is positive 41. So I have 2 solutions. One of them is this, with 9 plus the square root of 41 over 4. The other one is this one.
Okay.
So there are 2 solutions there.
I thought with the 2 solutions it was like 9 over 4 plus the square root of 41 over 4.
That's the same thing.
Okay.
That means the same thing. If you split that apart, 9 over 4 plus square root of 41 over 4. That's the same thing as this.
Okay. So
And if you do the minus, it's the same thing.
It's back from the old lesson. I thought there was just that specific way to have to do it.
If it's complex, we want to write them that way. If it's real, you can leave it here.
Okay.
That's where the complex is where we want to write it that way. So 9. That looks fun, doesn't it? 9 plus. It's actually the easiest thing in the world, isn't it? Or maybe not the easiest thing in the world, but 9 plus the square root of 41, and we're dividing that by 4. 3.85 is about what it is. We're going around to 2 decimal places. And then 9 minus the square root of 41. Divide that answer by 4. Net, and it'd be a positive 0.65. So go back to the original problem. What was the highest exponent on x? 4. Okay. How many answers do we have? Here's 1. Here's 2. How many times does 0 count? Twice, because it came from x squared. 1, 2, 3, 4. 4 answers. The highest exponent on x. 4. That always matches up. As we're doing higher degree polynomials from here on out, it always matches up. Whatever the highest exponent on x is, that's how many solutions we should be finding. Okay? All right. This takes